differentiability of a function? You have already studied limit and continuity, but the thing is, to understand differentiability, little bit discussion I'll do on limit and continuity. What does differentiability means? Both the meanings I will tell you, geometrical and physical. Both the meanings of differentiability I will tell you. First you write down the definition. So definition is, function definition you all of you know. Function has basically domain and then range. So we always discuss differentiability of a function on domain, not on other points. Okay. So a function is said to be differentiable at a point, suppose x is equal to a and this point is in D. Okay. At a point x is equal to a which belongs to the domain D, if derivative exists at this point. Derivative exists means what? It means derivative should have some finite value. Okay. At each point derivative should exist. Exist means value should be finite. Now what basically derivative means? Now I am telling you definition first. Definition means we just calculate, you know na, left limit you calculate, right limit you calculate. For continuity what you do? Left limit you calculate, right limit you calculate, and then value at that point also you calculate. If all are equal, you say that function is continuous. Here the thing is that you calculate right derivative at that point. Fine. This is right derivative at that point, then left derivative at that point, and this is the derivative at that point. The same thing is here for derivative also. This should exist, this should exist, this should exist, and both all these three should be equal. Now definition, theory definition is, I am writing this. So this is basically definition is, this is right, right means you will go little bit like A positive, little bit right to A, not like very far, but little bit difference, little it will be like, suppose this is the point, so A plus is like you are coming from this point with a very small distance. A plus means you are not going like A plus 1. This is not A plus 1. You will not jump, like jumping will be very small. This A plus means this jump is 0 0 0 0 0 0 0, very small. I hope you are getting it. This A plus means A plus 1, A plus 2, but this A plus means that this very minor plus you do, very small addition you do. Okay, so for right derivative, this you will check, and this is how, this is the definition, proper definition. This is for right derivative. What you will do, limit extending to a plus fx minus fa upon x minus a, you will calculate this value at this point, right? This is basically right limit. If this is finite, you will say right derivative exists. This is right derivative. Now for left derivative, what should be the limit? A minus, this is also very minor, very minor. So fx minus fa upon x minus a, and this all of you know, this is derivative at that point. So all three should be equal. So for continuity, I hope definition is clear to all of you. Is it fine? Now the thing is, there is a very like connection between continuity and differentiability, and that connection is it's a big note actually, every differentiable function is, this is notation for function, every differentiable function is continuous but not conversely. Any example if you know this? Yes, fx is equal to mod x. Just tell me, because if I'm discussing differentiability, continuity, I should know domain of this function. Then only I can go for go and discuss differentiability of this function. Now, tell me its domain. Its domain is, and its range is positive with 0. Yes, good. So fx is mod x. Now I will check, I will tell you the differentiability of this function now by graph method, by this definition method, and by direct method. Okay, then any of the method you can apply in a question, whichever method you feel comfortable. Okay, because sometimes all the time you cannot draw a graph of the function, all the time you cannot find limit by this method. Okay, so the three methods I will tell you, and this is simple example, so you will understand better. Is it fine? So I hope you have noted down. I rub the board. Okay. Continuity means graphically continuity means continuity means yes, curve without breaks. Differentiability I just tell you. First I just solve this question. So fx is mod x. So how fx is defined? X when x is greater than 0, x is minus when x is less than 0. First method is I am just checking continuity. Why I am checking continuity first? What's the use of? You only told me na this what's the importance now? Why I am checking? If suppose for any question, if I want to check differentiability, every differentiable function is continuous. So why I am not checking differentiability directly? Every differentiable function will be continuous. I want to check continuity and differentiability of this function. So why I am not checking differentiability directly? Okay, I am writing it. Every differentiable function you know continuous. Not continuous implies not differentiable. Can you say not differentiable implies something? Not differentiability doesn't imply continuity or not continuity. There is no use. But if function is differentiable, 100% that will be continuous. But if that is not continuous, then not differentiable. So always best way is always you should check continuity. It is the best step or best thing to do if you are doing differentiability and continuity. First you should check continuity. In case this is not continuous, no need to go for differentiability, because differentiability method is little difficult. It is bigger actually. You have seen the definition, na? Differentiability, if you will check, it is bigger method. By differentiability you can say continuity also. But if you go for continuity, suppose function is continuous, then in that case so you have to check. But continuity part is easy to do. Okay, you can see now continuity at x equal to 0. Graph also you know now for this function. This is actually very basic one. This is the graph.
Yes, sir.
You know how to draw this graph?
Yes, sir.
All of you know how to draw this simple graph. Now continuity at x equal to 0. How we check? First thing is left hand limit. We will check. This is left hand limit. So how we find out left hand limit? X tending to 0 minus and fx. Limit extending to 0 minus fx value. Now you check at these points function, how function is defined. At these points function value is minus x. Now 0 minus means is 0 only. It's near to 0. It's near to 0. So exactly 0. We put up 0. Now right hand limit we will check. So right hand limit will be 0 plus and fx. So this will be function value at this for these points is x value. This will be 0 only. Now the last thing, value of the function at 0. This will be 0. So by seeing all these, LHL equal to RHL equal to F0 equal to 0, this implies function is. Now the thing is, now you cannot say anything about differentiability. It is doubtful now. Function may or may not be differentiable. But we are very sure that continuity part we have checked. Now the next thing is differentiability. Okay, and by definition first I will tell you. And by graph also it is clear now that this function is continuous. There is no problem. And now we will check this. This part you see very carefully. Differentiability. Differentiability. How we check? Right derivative at 0 I will calculate. Then left derivative at 0 I will calculate. What is the definition now? So limit x tending to, this is right. So 0 plus and then fx minus f0 upon x minus 0. So this will be value of this for 0 plus points is x, f0 is 0 upon, so it is basically 1 you are getting it. Then for this limit fx minus f0 upon x minus 0. So 0 minus x minus, so this is, now you can see it, not differentiable. F is I just checked only at one point. I just checked, this is one method. This is one method to check differentiability. This is direct method. This is basically definition. Now in graph, how you check? This is your x equal to 0 point now. This point origin, 0 point. This is the point. In the graph, there should not be sharp corners. If there is a sharp corner at that point, function will not be differentiable. This is basically graphical meaning. Is it fine? And this is done now. Now I am telling you direct, how we do direct calculation. I just checked the differentiability by this definition. Now I am telling you how to check direct, how to do direct calculation. Right up the board? Okay. Now for direct. F dash x. You know x derivative is? X derivative is? 1. Minus x derivative is? Now you can see easily. This is what I did by definition. This is direct one. So it means for all those points greater than equal to 0, derivative will be 1. At 0 only the problem is, otherwise it is differentiable. You can see. You can take 1 minus and 1 plus. You just tell me right hand derivative at 1 and left hand derivative at 1. Tell me what will be this. For this function, right hand derivative at 1 and left hand derivative at 1. What is the value? Tell me now. Except by graph it is very clear that at 0 it is not differentiable. Otherwise it is differentiable na. So value will be same, but what value it has? Yes, 1 and 1. You didn't answer, so I thought that you are thinking and you don't know. 1 and 1. For now tell me right hand derivative at minus 2, left hand derivative at minus 2. Minus, who said minus 2? Minus 1 and? It is very clear na, for those points, for less than 0 points, this derivative is. So this is direct. It's up to you, like which method you want to apply. This is basically lengthy one, and sometimes this is helpful. When it is helpful, I'll show you. For which questions this will be helpful, for what questions this will be helpful. So I think after doing questions only you will get to know. So I rub the board. This question is very simple one. No need simple one, but you get to know, you have learned now 3 methods. Graph, this one, and these are the 3 methods only. These are the 3 methods. Other than that, there is no method to check differentiability. Then your mind only, how you are thinking on that question. If you can draw the graph, it is really simple. If you can draw any function, then no need to do this definition and that direct method. No need to do. You can easily answer. Okay. So I rub the board. Now tell me what about this function, because now every time we will not draw the graph. How many of you can draw the graph of this function? How many of you can draw graph of this function? Now I am checking differentiability of this function. Okay, one answer, because you have done limit and continuity. Is this function continuous? Is this function continuous? How it is continuous? Like on what basis you are saying that this is continuous? You should have some proof, na? Like on what basis you are saying that this is continuous? Yes. Okay, you have some more justification why this is continuous. We have seen graph of this function, you know. Draw. -1 shift हो जाएगा and then same V shape you will get. Complete graph, because now you have to check differentiability. Can you draw the graph of this function? Because continuity, by the fact, very good. A fact you use is, if f is continuous, g is continuous, then f plus g, f minus g, f g and f, provided at that point it should not be 0. These 4 properties holds if your function, if both the functions are continuous. Very good fact she used, but the thing is, now your fact will, how your fact will help for differentiability? Because I want to know differentiability, na? So 3 methods I can apply, but the thing is, you know the graph of this function, so that I can easily tell you that these are the points where the function is not differentiable. Okay, now let me do it. How you do it? First you break up mod x function easily. This is the mod x function. This is mod x minus 1 function, and this will be, if x minus 1 is greater than equal to 0, it will be x minus 1. If this is less than 0, then it will be minus of x minus 1. This time you don't have x, you have x minus 1. Now let me write this function. So breakup for this function is breakup for basically main disturbing points are 0 and 1. Disturbing points and 0 and 1. So I will divide the real line in with the help of these 2 points. Okay, I will divide. How I will divide? For x less than 0. Okay, for 0 less than x less than 1, and then 1 less than equal to, this is how I can divide now. The full real line I have taken, and only the point is, because function is changing values at these points only, otherwise function is same. So now tell me, for x less than 0, this value will be, mod x function value will be minus x. Okay, if x is less than 0, then it means x is less than 1 also. So what about mod of x minus 1 value? That value will be this or this. If x is less than 0, this is basically, I am just solving it little bit. This, it means x less than 1, for values less than 1, this is the value. For greater than equal to 1, this is the value. If x is less than 0, this is 0, less than 0, it means x is less than 1 also, na? X is less than 1 also, so it means which value you will take? This one. So minus x minus of x minus 1, this is the value. Now come to this interval, 0 to 1. 0 to 1 means when x is greater than between 0 and 1. How you check? I just tell you the simple method. How you check the values now. I think that will help you. Take any value between this interval. First very important value 0 is also there na. 0 value is very simple one. Put up 0 here. This is 0. So it will be positive. Fine. Now come to this. When you are substituting 0 here, this value is negative. It means for this interval you have to take negative of this. This is how also you can write it. So negative I have written. Is it fine how I checked? Now for this also I'll tell you. For all those points x greater than equal to 1, you have to check what value that function will have. Take any point. Take any point x greater than equal to 1. 1 is simple 1 na. 1 I can take. The very first one. So 1 at 1 this is positive. It means its value will be positive. Then for x minus 1 this is 0, so positive. Okay. So this is how we write the function. Any mod function now you can write down by this method. So fx ultimately what fx you got? Minus 2x plus 1, then 1, then 2x minus 1. Is it fine? Is it fine? Any mod function now you can explain now, you can write down. Graph easily now you can draw. Actually the problem is, I think little bit discussion I want to do. Mod x function is not not differentiable at 0. This function is also not differentiable at, it will 100% not differentiable at 1. So this is not differentiable, this is not differentiable. So like how many points we need, how many points this function is not differentiable? 2 points I have told you directly, because now you know the properties and all. Now I just draw this function. Draw. This is 0 point. So for x less than 0, your function is, so this is basically a line. How you draw a line? This is how you draw now. So x, y. For x0, value of y will be 1. For y0, value of x will be 0.5. Okay, so this is the function. So now tell me, okay, minus 2, 0, 1. 0, 1 point is, y is 1. So 1, 0 point, 0, 1 point is this. Fine. Then 0.5. 0.5 will be somewhere here. So 0.5, 0. This is the line. Fine. Now come to the 0 to 1 interval. 0 to 1 interval, next for x less than 0 we have drawn the function. Now for 0 to 1, what will be the function? At each point it is having value 1. At each value it is 1 na? Now for the next values it is, for x less than equal to 1 it is 2x minus 1. I just see this also. So 2x minus 1. So this will be x, y. So x0, y will be minus 1. For y0, x will be, for y0, x will be again 0.5. So this point and, so now you see the, this is the graph. Okay, see the sharp edges now. At 0 it has sharp edge. Sharp edges are this and two sharp edges you are getting. Two sharp edges, what happened? Two sharp edges you are getting, it means the function is not differentiable at 2 points. So, and here also I was telling you at 0 and at 1. So this function is not differentiable at 0 and 1. Is it fine? So any graph, any mod function you can draw now. Now conclusion is that, I have the board. Any conclusion is that every mod function is continuous but not differentiable accordingly. Now you can answer this also. Okay, now I think meaning we are leaving. Geometrical meaning and physical meaning. Geometrical meaning you got to know there should be no sharp edges. Geometrical meaning. Physical meaning basically what it gives you, derivative, what a derivative gives you? Slope. It gives you slope accordingly. It gives you slope, physical importance. Geometrically there should be no sharp edges. It means आपको clear हो जाएगा कि if the function is differentiable graph में there are no sharp edges. So accordingly that is geometrical importance basically. Physically you get slope. Physically you get slope, and physics also you say velocity also na, and double derivative you say, you call that acceleration. For rate of, basically rate of change also, dy by dx or f dash x, basically what we call it, rate of change at that point, particular point. Rate of change, yes, instant rate, instant change at that point. Is it fine? So now come to, you have noted down? One thing I want to know, whenever we are checking continuity and differentiability, value of that function should be defined at that point? For both continuity and, because why it is? Can we find out limit of any function except domain? Can we discuss limit? I am talking about, because you have already done limit now. I am checking differentiability and continuity on domain points. On domain points. Can I find out limit at a point which is not in the domain? Can I discuss limit concept? Answer me. Okay, now, okay, what about this function now? Tell me domain first. Domain of this function. Real values except? Can't you check limit of this at 0? You can. Tell me 0 minus limit of this is? Limit of this function at 0 minus infinity? We can talk. We can talk limit. But for differentiability we never bother. We never check. Is it okay? For limit we can talk limit of any function for like any point. For any point we can talk. We are not particular for domain. Is it fine? We can talk now. Here the limit is infinite. Hardly matters. Here the limit is, I know that this function is not defined at 0, but limit we can answer na. Limit is how much? Minus infinity. Limit is, we can talk. There is no problem whether this function is defined or not. But we can talk limit concept for any function, but the thing is continuity and for differentiability we never take any point outside the domain. Is it fine? For limit and continuity we never take. Okay? So now I think if you have noted down, come to this function now. Greatest integer okay, if x is less than 0, then how graph can go in positive direction? For the last question she is asking. So what was the, we did some mistake, or can I clear her later on? I'll draw the graph and then just write down. Something must be wrong then if she is asking. Otherwise I'll clear later on, because I have rubbed the board now and I don't have. Okay, now for greatest integer function, tell me domain and range. Then I'll discuss its differentiability and continuity. For greatest integer function, tell me its domain and range. Graph, I hope all of you know. Greatest integer function domain is? Real, okay. Then range is? There is no need of range, but anyhow I am asking you. Tell me. Range will be what? Yes, she is right. Set of integers. Graph is like open here, then this is how the graph goes. how many points of discontinuities, like what are the points of discontinuities for this function? At which points this function is not continuous? Tell me at which points this function is not continuous. And four properties also, four things also, you know, a function is not continuous if continuous at x equal to a, if f a is not defined. This is first thing. If value of that function is not defined at that point, function value at that point is not existing, then also you say no need to check then continuity. You say now directly that function is not continuous. Then LHL, I just write LHL RHL. LHL RHL both exist but not equal to FA. Then also it is discontinuous. If both exist and are equal but not equal to wait and are equal. This is second condition. Both exist and are equal but not equal to FA, then also you say that function is discontinuous. Now the third is if both doesn't exist, LHL and RHL, both or any, at least one of them doesn't exist. If at least one of them doesn't exist, then also you say now that function is discontinuous. Last point is both exist but not equal. Both RHL, LHL both exist but not equal. These are the four conditions where you say that the function is discontinuous. If the function is discontinuous, then function is not differentiable also. Okay, so I want to check differentiability of this function. But tell me where at what points this function is not continuous, because I'll be sure for those points for differentiability, na? Because I can't differentiate this function. Have you ever done a greatest integer function differentiability? Never ever. You never, na? But with the help of continuity I will do it. I will answer you. With the help of continuity I will answer you this question. On those points the function will surely not differentiable. So answer me, it's discontinuous point. Integers. At all integer point this function is at integer points this function is not continuous. Any sharp edges you see? Any sharp edges? This is the break. This is the break. This is the break. This is the break, and then this way you can go. It is basically step function. We call it steps. The graph is like this. Is we call this step function also. So this function is not continuous at integer points. So I can write now that this function is not differentiable at integer points using the fact only. Okay, so this function is not differentiable at integer points. What about other points now? Suppose you just take any point here. Okay, now I just write it, then I'll tell you. I'll use the direct method to see the differentiability at rest of the points. So I dub this line. How this function is defined basically? I just making the interval now. For suppose 0 to 1 I am taking, then 1 to 2 I am taking, then here I am involving 1, then suppose 0 x less than equal to 0. This is how I am breaking, just to tell you that how we check differentiability. Then 2 to 3. For x less than equal to 0, this value will be, I think this I can't talk, in interval we talk. For 0 and less than equal to interval I am making in a wrong way actually. Wait. This is how we cannot do it. Now tell me. 0 to 3 interval I am taking. For values 0 to 1, this function value will be 0. For values between 1 and 2, this value will be 1. For values between 2 and 3, this will be. Now you just tell me at integer points this is not differentiable. For inside points this will be differentiable or not. This answer you has now. You can see. Every time you are getting constant now. Every time you are getting constant. So derivative will be. Derivative will be 0. So on other points this function will be differentiable. Okay, no need to check, direct method you have and you can check it, because 1 minus if you take any point between here 1.5, you take 1.5 left and right, value will be 0 only. Then at everywhere you can see this is 0 0 0. So other points now you have seen, and this function is at rest points this is continuous now. On integer points this is not continuous. On integer points this is not differentiable also by the fact. Okay, but or for other points this is differentiable. Why I am not using this definition? Why I am not using this direct method? Can you differentiate this directly? You cannot. Directly you cannot know. You don't know, like d by dx of x is 1, but d by dx of greatest integer function you don't know. Then you have to split it and then only you can answer. Is it fine? So greatest integer function, differentiability and continuity we have discussed. Graph even we have seen, and by graph also it is very clear. Okay, now move to right up the board. Now what about last topic, like okay, inside points पे how your function is defined? I just write it 0 1 2, it was like this, 0 less than x less than 1, 1 less than x less than 2. Take any point here. Okay, so your right hand derivative at that point should be equal to right should be equal to left. Okay, so left derivative, direct method I am using. So value of function here for 1.5, value of function is, no, derivative is 0, value is 1. So fx is 1 for at 1.5, so derivative will be 0. So here it is 0, here it is 0, and you can check it for any point now. Any point you can take for this interval. For here also you can take any point. Here also you can take any point, here also you can take it any point. The derivative every time it is coming 0, because every time the function is constant in that interval. It is constant everywhere. So other except integer points, because less than 1 derivative is 0. For greater points derivative is, for greater points derivative is, you can check function value is, for integer points this will not be differentiable, but other than that it will be differentiable. This way you can check it. Okay, so now come to, okay, now tell me greatest integer value of pi is, greatest integer value of pi is, this is 3, this is 2. You know this function. Okay, now I am taking a question, split it. Okay, limit. Limit of this is what? Because I need these limits. Tell me the limit of this, then limit of extending to this. What are these answers? This value is limit you have studied. Infinity limit you are telling me now? Okay, you have studied it now? Fine. This also? Okay, now this? Okay, yes. This is 1. This is? Sure? No, actually, why I'm telling you all these things, because you have already done. You learned the direct method, or you do it by some calculation? Which calculation you are doing? Do it then. Because every time, every formula you can't learn. So we have a simple like method to know what value it will have. How you check? Tell me, you just take some time and tell me what value it will have. 1 is correct or some other value it will have. You are turning the pages. It means that you just you will see what value you are told. This is what I think you are doing. You do the calculation if you know the method. Do the calculation. This you told me infinity. This you told me infinity. All of you are sure. Okay. Now I am telling you this limit doesn't exist. Actually, okay, sine of any angle value lie between -1 and 1. You said at this point sine of 1 by x is infinity. Sine infinity will be between -1 and 1. You know na range of sine function. Sine range is -1, 1. Actually the thing is at this point na this is sine infinity. Sine infinity. This value will be 100% between -1 and 1, but we don't know what value it has. No, it is not indeterminate form. It is not. Indeterminate form, there are 7 types of indeterminate forms. You just learn those only. 7 indeterminate forms, and those are 0 by 0 first one, then infinity by infinity, then 0, then 0 into infinity. How many? 3. Yes, 0 to the power. Why this is indeterminate form? Because 1, if you multiply 1 infinitely times, why you say this is indeterminate form? There is a logic actually. You have studied indeterminate forms? Okay, first you come to this point first. Then I know. Actually the point is sine graph na, if you see sine of 1 by x graph, this is at 0 na, this is very black. If you see. You can see this, okay, on net. This is how the at here na at 0, this is like very black. You can't judge the value, and then this goes like this. Okay, this goes like this. So value will be between -1 and 1. That is very sure. But the thing is you can't tell what value it has. Now I am saying this limit doesn't exist because when you say limit exists, it means left hand limit equal to right hand limit. So this value will be between -1 and 1. What value it has, I don't know. This also, this will be on the negative side because minus infinity you will get, and this will be towards a positive plus infinity somewhere on this side. So the thing is that limit will not be equal. So we say that this doesn't exist. Okay. Limit exists means whenever you say limit exists means then it means limit, left hand limit, right hand limit. What you did, you just checked at 0 only. You didn't consider left and right part. You didn't consider na. Okay, so you please whenever you check, you always check the left and right. So left means minus infinity. Value will be between -1 and 1, but we don't know what value. But this will be this side, then this will be this side. So value will not be same. So same case here. Okay, first value also same. So these two limits doesn't exist. Now come to this value. This also I can tell you how we get this if you have done methods, indeterminate methods. How you get E value. You have learned this formula, na? You have learned this formula. So now the thing is, I think I should do these two questions. It will help you. This limit exists and this is exponential E. This is 1. Okay, simple one I am taking now. You know indeterminate forms, we all the indeterminate forms we have written. I just rub. Okay, now come to first this question. By this also you will get to know how you check, because this is simple one. With the help of simple one you will get to know. 0 by 0 form it is. Whenever you get this type of indeterminate form, what you do? You apply L'Hopital rule. L'Hopital rule is, hospital we don't call actually. L'Hopital, pronunciation is L'Hopital. We write hospital, but we call Hopital. Okay, L'Hopital rule. So L'Hopital rule basically is, you differentiate, this is 0 by 0 form, you will differentiate for the numerator function separately and denominator function separately. So function will be, value will be, log derivative is, this derivative is, x derivative is 1. What? L'Hopital rule is like, limit of this function exists. But the thing is, whatever methods you have studied to find out limits, that is not applicable. So we have another method to find out limit if the limit are basically the function are after substituting the limit, the forms are of these 7 types. There only you apply L'Hopital rule. You have many formulas for limits, but the thing is, if when you substituting that value 0 and you are getting 0 by 0 form and infinity by infinity form, you have which method? For such limits, for such functions, you have these. Actually, this form is one of out of these 7 forms. So you will apply L'Hopital rule. This is fixed. For indeterminate forms, these 7 indeterminate forms, there is only one way, and this is the only way. Okay, so this is the method, or what limit you are getting now. When you are substituting 0 now, there is no problem now. So 1. So this is how we learn formulas for limits. If you forgot, you apply these formulas. This is which form? 0. So 1 to the power infinity. And whenever you have power, you apply log. That is the only option. So I do it. This question also. So take this. Let y is 1 plus x whole power 1 by x. Okay, I am just telling you how you are getting e. So y is this, apply log on both sides, that is the only way. 1 by x log 1 by x. You want to know the limit at x tending to 0, apply both sides. Here there is no problem because there is no x, this will be as it is. And log y is basically what? Log y is what? Log y is this, log of this. Okay, log of this. Now just tell me, Abhi, recently I just checked it. This value is 1, na? We have already checked. Again it is 0 by 0. We will apply L'Hopital and we will get the value. So limit of this log y is 1. Here there is no x. So there is no point. I can remove this limit now. So log y is 1. So y is what? Limit. Oh, okay, I should not remove this limit. This is helpful actually. So limit. So limit of y is, limit x tending to 0, y is e, na? So limit of x tending to 0, y is what? This. So any question, any limit question you can answer. Is it fine? Now you can answer this also, but I think you have learned it. Sin x by x. Same formula you apply. You have learned it, na? Same formula you have. This is 0 by 0 form. Apply it. Cos x by 1. Cos 0 is 1. Same here. Limit x tending to 0. 10x by. Now tell me, is this true? Now just to check your, because you what is wrong with this formula? This. Okay. So what is wrong here actually? We have one formula, na? X. We don't want x actually. Yes, 1 by 0. So basically for this sin x by x, limit x tending to 0 is 1. For this also 10x by x. But here for cos x, simply cos x value is 1. Okay. So done? Limit. Okay, yes, I'll discuss this. Because one, when you solve, no, what's your name? Shiva. Shiva, actually the problem is when you put value, na, 1. So what you do, how you put up the value, 1 plus 1 minus, exact 1 you never. But anyhow you put up that 1. Okay. So 1 to the power infinity, why it is indeterminate form? If anyhow in question, exact value 1 you are getting, in any question, I don't have that question but it is there. Suppose you are solving one question and when you substituted value, suppose x equal to 0, this is infinity. So somehow because this is now, this is x equal to 0, so 1, exactly 1 you are getting. It is not tending to 1, it is not approaching to 1, this inside portion, this base. So if it is approaching to 1 and it is power, its power is infinity, then we cannot say that this will be 1. In such a case, we say this is indeterminate form. But exactly 1 if you are getting, na, that's like here also. If you put 0, you are getting exactly 1. So 1 to the power infinity will be 1. You can multiply 1 like infinitely many times, you will get 1 only. But why we call 1 to the power infinity indeterminate form? It means whenever there the problem is that this is approaching to 1, it is not 1. So you can write it. You will have a function where the function will approach to 1, not exactly 1. It is approaching to 1 and that function power is infinity. Then you will say that that function is basically, that form is indeterminate form. Is it fine? So that is why, otherwise 1 to the power infinity is 1. But for such cases where this is approaching to 1, there only you will say that this is indeterminate form, otherwise you will not. Okay? Okay, I rub the board. So limit, I hope ki if you forgot any formula, apply L'Hopital. Any formula you forgot, because L'Hopital is only for such formula, for such functions only. L'Hopital is only for such functions. I will not ask you limit extending to 0 sine 0. I will not ask you. You know the answer. This is not a formula. This is a direct value. This is direct value. This is basically, you need formula for this. Otherwise you cannot answer. Now do you know, because every time you do it. Okay, now move to okay, take one question, and this is, I think, also basic one, but lot of things to discuss on this question I'm taking now. Have you checked continuity of this function? Have you checked? This question is done. Now for this question, this is also important one. I will check, examine continuity. In general, I'll do it. Okay? In general. If, I think first I should do it. Examine continuity and differentiability. This is clear now that this limit, because sine 1 by x has come, so this limit doesn't exist. Okay, this doesn't exist. Okay, this is the problem basically. So examine continuity and differentiability of this function at 0 at origin. And one more thing, check f dash continuity and differentiability. Derivative continuity also we will check. Okay, so how we will do it? For continuity first, continuity at x equal to 0. How I will check? Left hand limit should be equal to right hand limit. Okay, so limit you just write down, x tending to 0 minus 0 minus fx, and fx value is yes, x to the power m. Now this value will exist only if this m is, I need one x actually. Why I need, I just tell you. First I think a little bit discussion. This doesn't exist now, but as I told you, this value, this is finite value, but lie between -1 and 1. If I multiply this by 0, you will get. You agree? So if I want to make this limit exist, I want this limit exist because I want to check continuity, na, where this will be continuous. Continuous means both limits should be equal. Where the equality comes, it means I need one x here, at least one x, because this is finite at 0, and 1, if I multiply, if 1 x I have, then if I will multiply this number with 0, it will become 0. So at least 1 x I need. It means this will be 0 if m is at least 1. Okay. So continuity thing now for RHL you just check. The same thing you will get. Same thing you will get. No need to write now. Same thing, because function for x not equal to 0, function is this. So same thing. It means continuity thing will come if and only if m is at least 1. If I just ask you continuity of this function, you can easily answer now. If I ask you, suppose this is the function, what you will say? I ask you continuity at 0. This function will be continuous. I have given you condition also. This function will be continuous if and only if m is greater than equal to 1. It means at least one x यहाँ पे you need, and there is no x here. So this is not continuous. Direct. If I ask you this, it is no need to check now because I am telling you. What about this? Now I think now onwards it will be continuous. Is it fine? So you got to know. So for continuity, at least one m x you need. Why? The reason is because this limit is finite. But it is finite. But anyhow, to make it 0, I need 1x. So this is the reason. Is it fine? So you can write it down. I just check now differentiability. For continuity, m should be greater than equal to 1. Come to differentiability. Differentiability at x equal to 0. So differentiability direct is direct I will not do, or direct also you can do it. Direct I do it. Direct means derivative will be what for at this point. RHL left hand derivative and right hand derivative both will be equal and value will be mx minus 1, then sin 1 by x as it is, then plus sin of 1 by x, oh sorry, cos of 1 by x minus 1 by x square and then x to the power m. So this becomes ultimately m minus 1 sin 1 by x. I think this will be difficult. Very sorry because I know it. This will be difficult. Apply the definition. Very simple it will be. So left hand derivative I am writing. So left hand derivative will be, and you will also get to know why that was a difficult one. Limit extending to 0 minus will be this. This is the formula. Fx value is xm sin of 1 by x minus f0 is 0 upon x. Limit extending to 0 minus. Limit extending to 0 minus. This value will be xm minus 1 sin. Now you can easily answer. For differentiability, this should be at least 1x you need. So it means m minus 1 should be 2. This limit will exist if and only if m minus 1 is greater than 1. It should be greater than or equal to 1. So it means m greater than or equal to 2. So for differentiability, it should be 2 and more than 2. For continuity, 1x will work. Okay. So what about this function differentiability and continuity now? What about continuity and differentiability? Okay, f is continuous but not. You can check it also na. If you can check it also. It will be differentiable. So oh sorry, not differentiable. What about this function now? This conclusion is for the this is for this function. If I just change it to fx equal to x square sine 1 by x not equal to 0. What about this function now? Both continuous and differentiable, because we have checked it. Actually now you the definition, the direct method was lengthy now. In direct method we got two parts, first and second. So analyzing first and second was little difficult. This one is simple one. By definition, direct definition, this is simple one. So conclusion is, we have the conclusion, this is continuous and differentiable at 0. What about derivative now? Ultimately we have to find out the derivative. I rub the board because I have to check the continuity of derivative now. Come to derivative. Derivative was what? F dash x was mx minus m minus 1 sine of 1 by x, then cos of 1 by x and minus 1 by x square into x ki power m. Okay. So ultimately xm m minus 1 sine of 1 by x plus x to the power 2 minus m. Oh sorry, m, this is actually in multiplication, m minus 2 cos of 1 by x with minus sign. Now tell me, for first part, m value should be, this is f dash x. Now we have a new function. This function continuity differentiability I want to check. So this is new function now. So for this function, what your conclusion is? This is your answer. So how you got it? How you summed actually? Because we have two parts, 1 and 2. So for one part m should be this limit. Basically if this is continuous, limit should exist at 0. If this is f dash is continuous, what? Okay. Anyhow her answer is correct. So I just justify. F dash is continuous if you will get to know why your answer is like, because you are too fast to answer. F dash is continuous if and only if left hand limit of f dash will be equal to right hand limit and it should be equal to 0. Okay. Left hand limit of f dash, if you left and right hand calculation will be same because function is same na. For left and right points function is same, so value will be this. This is basically, it is not simply x, both I am calculating. Okay, in my mind negative side is there, positive side is there, but it is not exactly 0. Okay, I hope you will take care. Now tell me for this part, if this limit part, this limit will exist, so if and only if m minus 1 is, okay, this part limit will exist. It means what? M is, this means what? Now you said m2, she said 3. I just justify now. Limit will exist when m is greater than equal to, m is greater than equal to 3. You always take intersection part so that complete value should exist. So this is 2, this is 3. One is saying that this limit will exist only if and only if m is greater than equal to 2. Only this limit. This limit will exist when m is greater than equal to 3. When both will exist together. So both will exist together. This is for the first one, this is for the second one. First will exist when m is greater than equal to 2. Third will exist when m is greater than equal to 3. So I think for all these points both are existing. For all these points both are existing. So answer conclusion is, for m greater than equal to 3 limit will exist. Matlab function will be continuous. What about differentiability now? Continuity I have checked. Differentiability. Okay, you are sure because I haven't checked. So 3 or 4, I think it will come. So answer will be 4. Okay, for 4. So I hope this type of question you got to know how we are checking. If I ask you, you have noted down? If I ask you this question, what will be your answer? Please take some time to answer. What will be your answer now for continuity and differentiability of this function now? What about this function? The same one actually. The procedure is same. Answer quickly. For continuity, what MLUs will we are getting? What? Actually, at point is 0. At 0, we are checking. Okay, point is 0. So you are saying continuity will. Okay, actually, the way you are answering not clear. 1 or 2 interval you are telling me. M values basically we check, na? हाँ तो 1 और आप between 1 and 2 लाई करवा रहे हो. All agree? All agree 1 and 2 it will lie between 1 and 2. I don't know how much calculation you are doing actually. I'm just doing it now. It is very simple. Left hand limit at 0 basically I'm checking continuity. So left hand limit of this function, left hand limit of this function at 0 and then RHL. Okay. I don't know what you are doing. So limit left hand limit means this. Okay. Right hand limit means this. So it means what? Limit extending to 0 minus fx is xm cos 1 minus x. I told you that this limit doesn't exist but this is finite. Okay. So again the same situation 1x I need for continuity. It means m should be. So it means m greater than equal to 1 means what? All the values 1 onwards all the values. It is not one value basically 1 onwards all the values. So many values actually. Is it fine? So you said 1 and 2, between 1 and 2, that I got confused. What was your like basically, I don't know what values you were telling me. For differentiability 100% you will get, for continuity of derivative you will get this, and for differentiability again you will get this. Is it fine? Okay? Okay. So you can note down and come to next question. You took a lot of time. So is it difficult? It was same na. Instead of sine we are having cos, and cos limit doesn't exist, sine limit doesn't exist. So same pattern, same solution actually, and same values. I have the board. Okay, now this fx is equal to only continuity basically, because you people are doing you have to determine values of a and b for which this function is continuous at 0. Do it please. Let me check now, because in continuity you have actually a lot of problems. Tell me a and b, still you have problem? What happened actually? Nothing. Actually we are just focusing on m only. If suppose I just remove this m, suppose just I remove this m, so ultimately for continuity what you check? Left hand limit, right hand limit. So right hand limit will be 0 plus sine 1 by x, and this you know doesn't exist. Okay, so you need 1x at least to for this function to be, so it means this function is continuous, this function is continuous, this function is continuous. So many functions you got now with the help of that m value. Okay. Now tell me for what values of a and b this function will be continuous at x equal to 0. Continuous means f0 is equal to right hand limit equal to left hand limit. Please do it and tell me b and a values, what values you are getting basically. This is yours. What value? Okay, wrong answer. Check it. Why? Like first you said -3, then you changed it to -2. Yes, -2. Why you are getting -3? This is very simple one basically. Only a value is little like you have to analyze. Yes, b value -2. Now come to a. All are getting? Anyone? Very simple, no? Very simple. Tell me a value now. A value. Please think about it, then I'll tell you. LHL, RHL, okay. LHL, RHL equal to F0. So LHL is limit extending to 0 minus, and your 0 minus function is ax square plus b, limit extending to 0 plus, your function is this, and then this value is 0? No, this is not 0, this is b. Okay, so when you are substituting here b, you are getting b here also, so b equal to when you are substituting 0 here, so -2. So one value you are getting, and you know continuity, for continuity you have this condition only. Now what you will do to find out a? You need some more condition, na, or something. So just answer me, only just answer me, b value is -2. A value anyhow not creating any problem, because when you are substituting 0, it is becoming 0. It means a value not creating any problem for continuity. Are you getting it?
Yes, sir.
B when you are substituting 0 minus, this is you are getting it 0. It means a value you can take anything. So any real number you can take, and then there is no problem, na? A value. So it means a is any real number. Is it fine?
Yes, sir.
It will not create any problem. You can see it. You can put up here 1. You can put up here 2. You can put up here 3. Any number you put up. Okay, so when you will multiply this by 0, so it will become 0. Is it fine? So A is any real number. So this is how also you think. So continuity, because continuity property you used to and you got only one value. For the other value you just analyzed your problem, that how your A is having, like how your A is basically helping. So A is helping in the sense A is becoming 0, because at 0 you are checking. Is it fine? So now take one more question now. How you got -3? Okay, by mistake. Okay. So now take this question. What about continuity and differentiability? Check it quickly. Continuity you just check quickly. Differentiability I will tell you. At A basically. A is only problem, not troubling problem. A is the only problem where the function is changing values. So f dash x will be continuous, both values are zero. Function is continuous. Okay. In case, because I have to check differentiability also, na. In case you got suppose you are getting you got this not continuous, so no need to check differentiability. Straightforward you can say not differentiable. Okay. That is why I told you to check continuity first. Is it fine? Now come to differentiability. So derivative, okay, now derivative we will check at x equal to, at x equal to, this value is basically at A. Now left hand derivative at A, right hand derivative at A, and then the value. Okay, so right hand derivative will be what? Right hand derivative means limit extending to A minus fx minus fa upon x minus a. So this will be, fx is for less than values, x square upon a minus a, fa is a square upon a 0, fa is 0, limit extending to a minus x upon x minus a. So this is basically limit extending to a minus, this becomes the numerator, x square minus a square upon a only, and 1 upon x minus a. So you, when you will factorize it, x minus a will cancels, and then x plus a upon a, and when you will substitute a, it will be so 2 only. Okay, so left derivative is this, right derivative is, right will be limit extending to a plus fx minus fa upon x minus a. Okay, now tell me fx for positive a, this is a minus a square upon x, fa is 0 upon x minus a. This value will be what? So this is ax minus a square upon x into limit extending to a plus. Some problem you are getting here? Something is wrong or some problem now? Tell me what problem basically. Tell me. Can you find out this limit? Which form you are getting? Indeterminate, na? So I'll to find out this limit, what I will do? I will differentiate, because 0 by 0 form basically. Nothing is cancelling and all. So apply L hopitai, and after that this will become A minus A only, and this will be 2x minus A. Again now this is simple. A upon A 1 na? 1. Now this is 2, this is 1. Clear cut that this is not differentiable. Directly tell me f dash x. F dash x for this case is 2x by A for first one. For the second one it is minus A square, as it is 1 by x derivative is minus 1 by x square. Is it fine? Direct method actually I am telling you. Now for A left it is A by A, so 2 left derivative. For right values it is A square when you will substitute, so minus minus plus, so 1 only. So this is not differentiable at, this is direct method. Which one? This one? This one? Just substitute A now. So A upon 2A minus A upon A 1. Then this is by definition, this is direct one. Because this is you get less time in your exam, so this is direct one. So I told you, I just showed you that this is 2, this is 1. Direct method is, this is direct derivatives, you know how to find out derivatives. So now for the left points, just substitute A here. So this will be 2A by A, 2 only. For the right points, this will be plus A square by x square, so 1 only. Direct is simple one. Sometimes it is not helpful, sometimes it is not helpful. Like for the I was in the previous question, this question, this method helps. This was bigger one actually. I was getting 2 parts. So you just see which one will help you. But for such questions, direct method you can apply like this. Is it fine? Graph even you can't draw. Graph is very difficult. So you can note down and come to another problem now. Okay. So I hope you will take care in limits. If 0 by 0 form you are getting, and in formula also, if you forgot the formula, then also you just apply 0 by 0 in that L hopitai rule. Easily you will get your answer. I rub the board. Now for continuity, you got to know that if two functions are continuous, then there's some difference, multiplication, division will be continuous. Same facts are if f and g are differentiable functions, then their sum and subtraction, their multiplication, their division will be differentiable. And you know, for this, if the function of this type derivative will be this, separately you will differentiate and then you will answer. For multiplication, you know, first same, second derivative, first derivative, second same. This is the rule, product rule you apply. For this, and gx should be not equal to 0. This is the condition. For this, you know, g square, f same, minus g f same, then g dash. These are the 4 rules. Or this is product rule, this is quotient rule. So this is also true for any function, for any two functions, if they are differentiable. Is it fine? Yes, but the thing is, I don't know, converse, you know, if f and g are differentiable, this holds, not conversely. Conversely means, suppose sum you are anyhow given, that sum is differentiable. What will be your answer for f and g then?
Maybe differentiable.
Yes, may or may not be. I take one example. for differentiability basically. Why I am telling you? You must be thinking now that ma'am, if f plus g is differentiable, why f and g are not differentiable? It is like that. It must be 100%. It is coming now. So I just give you example. There is one example. Suppose fx is this, and then this g. Okay, sorry. Suppose f is this, g is this. Sum you just see. Sum is 0. Sum is differentiable, but you know these two functions are not differentiable. But anyhow, to me also, if f plus g is differentiable, why f and g are not differentiable? So it comes in your mind, so you can write down this example. Same for multiplication. You multiply these two functions, fg will be minus x square, and this is parabola. Parabola, you know there are no cuts, there are no gaps. So this is, and there are no sharp edges basically. Differentiability we are discussing now. So there are no sharp edges now. This is parabola. So this is differentiable. And now one statement I want to tell you: every polynomial is differentiable. This will help you. Every polynomial is differentiable. Any other function you tell me? Okay, tell me any a function having 3 points of 3 points where the function is not differentiable. A function having 3 points of not differentiability. Tell me. I have actually in this lecture it has already done. It is done. A function 3 points of 3 points where the function is not differentiable. This is the function. No points, you can take any point. Okay, so these are the points. Suppose. Tell me the function.
Mod x plus
Yes, mod x.
mod x minus 1 mod x plus 1.
Tell me a function which is not continuous at 3 points. Not continuous at 3 points. Quickly, tell me. You have done that question also. A function which is not continuous at 3 points, exactly 3 points. It means at 3 points, on those 3 points, the function is breaking, having a gap. So any function with gaps, if you have studied, greatest integer function. How many points I told you? 3 points, na? So how you will define it now? Within interval 0 to 1, then 1 point you will get 1 to 2, 2 to 3, 3 points you got, then 4. 4 points, 0, 1, 2, 3. Okay, for continuity also, suppose I just define my function like this. So this is basically 0, 1, 2 and 3. At 0, how you will check the continuity? Because at greater part is not there, less part is not there. Greater part is only there. So how you will check continuity at 0? How you check? If I ask you whether this function is continuous or not, anyhow you know it that this function is not continuous. For 0, how you will check it? Actually at 0 is very important. I said at 0 it is not continuous. I said it, na? Somehow I am wrong. Why I am wrong, please check it. Why I am wrong? For any point you check left and right. This is okay. Left limit means limit extending to 0 minus. Right limit means 0 plus. F0 basically F0. Here in this question, if my left limit has no meaning, I am not bothering now because my function is within the interval 0 and 3. So these points, my point is 0 to 3 I have to check continuity. So it means for points on left of 0 I am not bothering now. I am not bothering. So it is wrong to say that this function is discontinuous at 0. But if I extend it, na, this interval, if I take this, then I can say this is discontinuous. Then I can say. But just see the situation and then answer. See the situation and then answer me. Do you think that at 0 this function is discontinuous? Do you think? It is wrong. LHL is doesn't existing and we don't bother, doesn't exist and we don't want to see because interval in this interval we want to see basically. So in an interval if you are talking, then it means this interval is starting from 0 onwards, 0 and then 0 onwards. So left limit you will not check. If I ask you just check whether this function, you know greatest integer function has how many discontinuities? All integer points. If you are talking in general, if you are talking in general, but if I fix up this interval and if I ask you tell me its point of discontinuities, you will this is wrong actually, I have written 0 here, 0 0 I have included, but now I will tell you left limit you will not check because that is not coming in our interval. Okay, so at 0 it is 0, for right points it is, so both are same na, left limit we will not check, so this means it is continuous at 0 in this particular interval. Is it fine? So if somebody asks you just tell me just answer whether this function is continuous, points of discontinuity of this function in this interval, you will not include 0. I hope you will take care of this point. Same case, I just rub it. Same case for 4 now. For 4 only you can check left only left. Okay, so only left you can check, so at left it is 3, right you cannot talk, on that point you cannot talk, so there is no point. It means at that point the function is continuous. ठीक है, at this point this is continuous, at this point this is continuous, so point of discontinuities are 1 2 3, but actually I asked you 3 points only na. So now you can draw also, just draw this function. So 0 to 1 this is 0, then 1 to 2 it is 1, here open, then 2 to 3 it is 2. What happened? Something wrong? Now only in this interval we are talking, and I am asking you where this function is discontinuous or not. At this point we cannot we cannot talk these points. These points are not bothering. So from here to here, see the discontinuity, this and this. Okay, so these are the points where the function is discontinuous. Is it fine? So at 0 you will not go below on the left of 0 you will not go. Is it fine? I hope. Is this question okay or not? So if you talk in an interval you have to be very particular. What limits you can find out for this, you can find out only right, and at that point only you can find out right. Left limit you don't know and you will not check, and directly you will say at this point there is no break because you are not including that portion. Is it fine? Now come to, okay, this is okay. Okay, some more, one more question I am taking. So it means a function is continuous on an interval if you have you done it continuity on an interval, because the same thing I'll do for derivatives. Have you done it? Continuity on an interval. Suppose this is the interval. So it means A is there and right part is there. So for continuity, what you will check only at that point and then right limit. For B is there because closed actually I have made it. So B is there and right is there. So for if I ask you check the continuity at A and B, for A continuity you will check right limit and limit at that point, value at the value of the function at that point. For B, what you will check right left limit and then value of the function at that point. And if they are same, you will say this is continuous. You will not check right and left. I hope you got it. Same thing for differentiability. So differentiability on an interval. Suppose this is the interval. Okay. What about this interval? If I ask you continuity at A, what you will do now for continuity? Only right limit you are getting at A. At A you can't do it, you can't check. For B also the same thing. For B also the same thing. Now for differentiability, which derivative at A you will find out. Basically, I think three things, these things I just write down. This is continuity definition. This is continuity definition. This is continuity definition. You say this equal to this equal to this. If they exist, this condition also you put up. If they exist and are equal to this, then the function is continuous. So for this case, it is very clear now which limits you will find out for this also. Now for derivative, which derivative you will find out? For this you will find out right hand derivative. So only right hand derivative at A. And for this, if these two exist, yes. And for midpoints also you will check. In between points also you will check. It is not that directly you are saying. Suppose function is differentiable at here, function is differentiable here, but inside it is not, then it will be a problem. So I am just telling you, if you are checking on an interval, what you will do at endpoints, this is the way to check differentiability, and for midpoints, for the in between points, you will check by the method. We have procedure. Okay. So for in between points, you will check by that method, but for this you will talk only right derivative. For this you will talk only left derivative. Okay. Now take one example. Write down fx is x square ax plus b, and now I will apply the direct method, because now you got to know is a and b, find a and b values for which the function is differentiable at x equal to c. Okay. Your function is given that at C it is differentiable. You have to find out the values of A and B. So first thing what we do? Only definition you will apply. Direct I do. Direct derivative will be, because that will help. Direct derivative will be A. Okay. It means at C right hand derivative will be equal to left hand derivative. This is the condition. So 2c will be, A will be equal to, very simple. How we find out now B? Because only one condition we have, and with the help of that condition we are getting B, A only. How we find out B now? Okay, now I just give you 1 or 2 minutes to think. What will be, what value B will have now? Any real number? Okay, now I just, you said any real number. I am taking it, any real number now? A value I am substituting here. You are saying that this will be differentiable for any B. Okay, I am putting that value and I am checking whether your answer is correct or not. As you said it. You should know, like whenever you are saying, you said 2C value is final. 2C value is final. You are saying any B value. Okay, I am taking B0. Okay, I am taking B0 as you said it. Now check differentiability. I think easily you are getting it. Derivative is 2C. Derivative is, you said, ma'am, any B value will work. You said it now. At C it is not, now it is not differentiable at C. This is 2C and this is 0. So what should I do? Thinking part is over now. Can't think what value B will have. Or you can think, it is not hard and fast rule, you can think. Everybody has mind. Good mind, bad mind, that. Tell me.
It is AX ma'am, so we should write it 2CX.
2C? No, derivative actually I have written here.
It should be 2X.
It should be 2C only.
X.
Wait. For x greater than c, this is the value. Derivative will be a only. A value is, so that's what I wrote. Okay. This is derivative I have written.
And then it should be 2x.
2x and then 2c. Yes, okay. Yes, it is working. So now b value if you take as anyhow your answer, any real value, your answer is working. But the thing is, I just take now c can be 0. So now take under root 2 will also, I think it will. Wait. Let me check now, because why I am giving you time. Anyhow, your answer is not contradicting the fact, but because the values are anyhow different. So let me think now. B value, if you are taking 0, 1, 2, because when you will differentiate it, it will hardly. This value is has no contribution actually. It will become 0. Okay. So now I think 0 then. 2c, it means at c it will be differentiable 2c and then 2c. Here also I was getting value at c is 2c. Yes, continuity part is breaking. At 0 it is giving you this is 2c square when you are substituting, and then no, it will be 2 and then a is 2c, so 2c x is c na, so 2c square, then b value we are taking 0. Very good point which I was telling you, which I was about to tell you, it is breaking. Okay. So why b value is not working? Because continuity is breaking, then that fact is anyhow wrong. Now how? Because only one condition you got to know, a, every differentiable function is. So now to find out b value I will apply that property. It will be, yes, you got it. B value will be, every differentiable function is continuous, so continuity at c will exist, function will be continuous at x equal to c. So continuity means LHL, as this function is differentiable at x equal to c, so this implies function is continuous at x equal to c. So it means LHL equal to RHL equal to f of c. Actually this is c. Now come to from here, what you will get, LHL will be this x square, and when you will substitute, okay, limit extending to c minus fx equal to limit extending to c plus fx equal to f of c. F of c is c square. So this is c square, this is also c square. From here what value we are getting? 2c x, and that is c square plus b. Okay, so b value is, b will be minus 2c square minus plus c square, so b is minus c square. Is it fine? So for differentiability, if you have this type of problem, what you will do, differentiability is there, one value you can find out from there, and then the other condition you will apply is continuity. Very good by the point she thought about. It is good actually. This is this type of mind actually you need. So continuity is breaking for that for your values. So every time don't stick matlab that in last question it was any real value, so for other also it will be. But you are learning concept, so I hope ki you will apply this. Differentiability implies continuity, so continuity fact I used and I got the value. Actually she said b0 and even function was it was like that this is differentiable, but this was breaking. I used continuity part and I got this value, so it means these value only will satisfy. If you will take a 2c and b minus c square, then only your function will be both continuous and differentiable. But if you take any value here, it seems that this is differentiable, but it is not. Okay, I hope you will take care of this because continuity is breaking in that case. Continuity is breaking in that case. So it is okay. So now take another question, and in that question we have 3 variables this time and some other condition also there. Right up the board. The next question is fx is equal to ax square plus 2x minus 1 b minus c by x square for x less than equal to 1 for x greater than equal to 1, where a, b, c are constants. It is given that function is differentiable at x equal to 1 and f dash 0 is f dash 2. You have to find the value of b. Find the value of b. Okay, so how many conditions we have this time? Three constants, basically 3 values we have to find out. One is differentiability at x equal to 1. One is this, and another you know now. Another is continuity. Okay, three conditions we will get, and with the help of those 3 conditions we will find a, b, c. Only b actually we want. So first thing will be, I just solve this first. What does it mean? Tell me. F dash 0 is equal to f dash 2. What does it mean? Value of the derivative at 0, and this will be how much? For? I just write down direct method. That will help now. So derivative will be 2ax, then minus c, and x 1 upon x square derivative will be minus 2 by x cube. What happened? This is direct derivative, no? I will not apply that formula and all. Okay. So now f dash 0, tell me. F dash is this. So at 0 it will be? It will be 2 only? Yes? No, minus 1. Actually something is already on board. This is minus 1 only. Some scar type of black mark is there. So 2 c by x cube. So f dash 0 is 2. F dash 2 is? F dash 2, who will answer? 4a. Please take care of the points. Add 2 function will for x greater than 1, this is the derivative, and 2 is greater than 1, so derivative will be 2c by 2 cube. So c value is 8. 2c value is 8, but I don't want this value basically. Any problem? Derivative is 2ax plus 2 and then c into 2 by x cube. This is the derivative, and points also I have written. Now tell me one value I got to know. Okay, one condition. Now differentiability at x equal to 1 means a right hand derivative at 1 equal to left hand derivative. So the values will be right hand derivative value, tell me please, at 1, and then left value and then right derivative values at 1. 16. What 16? 16. You are telling me answer, I think. Or this value will be what? Right derivative at 1. 16. Okay. And this is? I'm surprised actually how you are getting 16. What you are doing basically? Okay, fine. 16, then this is? Then this is left hand derivative. It is clear to all of you? Is it clear? No, it is not. I write it down. 1 means at 1, right, left side, right side of 1. Right side of 1 derivative is this. So this is c2 by x value is 1. X value is, c value is, so they are substituting. So 8 into 2 is 16. Left derivative means left value at left values. So 2a plus 2 and a value we don't know. So 2a plus 2. So this implies 2a is equal to 14 and then a is. Now again the issue of b value. Okay. And b value we will get by the fact of continuity. So function is differentiable at x equal to 1. This implies function is continuous also. So continuous means left hand limit equal to right hand limit equal to f of 1. So left hand limit is 2a plus 2. And then right hand limit will be, actually I am doing wrong. I am just putting in, there should I put up, this, that is the function, and derivative actually I was putting. I thought that this is same thing I am getting. So LHL will be, a value also I can substitute. So 7 plus 2 minus 1 equal to, right is b value I don't have, then 8 by 1. Okay, f1 is again I think same value, this. So I am not writing. So now 9 minus 1 plus 8. Yes, b is 16. Is it fine? So any interval you can answer like where the function will be continuous, differentiable, and then this is how you can find out the values also. Okay, now 2-3 things I think you will be able to answer, but I want that you answer. I just rub the board. Signum function you have studied now. This is very simple one, it is not difficult one. Signum function is one for greater values, minus 1 for less values, and at 0 it is 0. Just tell me limit extending to minus 2 minus, limit extending to minus 2 plus, limit extending to 1 minus, limit extending to 1 plus, limit extending to 0 plus, limit extending to 0 minus, its domain is real, range is 0, 1, minus 1. What values are you are getting? Less than? This will be? This will be? Minus 1 or some other number? Then for this? Minus 1? Then? Okay. Please check it. You are thinking a lot. I thought that you will easily answer. This will be? This one? Okay. Wow, great answers you are giving now. To chalo. 0 you said na. Chalo. Let me know like why you. No, let her now because others are. You said 0. Why you said 0? I want to know actually. Because where you are doing mistake. Now I just want to know that. Why you said 0? There must be some reason, na? You have checked something on the basis of that only you are saying that this will be 0. Just tell me. Let me know let me read your mind. Why you said 0? Very simple thing actually I am writing. But she said 0. It's a big thing now. It's a big thing to me now. So why you said 0?
Because for a greater than 0 it is coming 1. Then for then we are going
Left. It is minus 1. So which side we are going now? 1 minus mean 1k, it is so near. It is so near to the left. 1 minus mean it is very near to 1 only. We can't go to 0. Jumping is very small. I told you na in the beginning. This 1 minus doesn't mean that this. I think what you thought. This one. 1 minus means you are in neighborhood of 1 only. You are in. This is very small. Please just make it a point. This is like I even can't draw here. This is like very minuscule. Very 1 minus means very near to 1. Very near to 1. But on the left. Very near to 1 on the left. So it means like this number 1 minus means where it will come now? In which interval? Partition is how? Partition is how? At 0 the function is 0 only. Okay. And then 1 at for less than 0 values it is minus 1. So minus 1, and then for plus values it is 1 only. So now tell me minus, I asked you 1 minus na. So 1 minus value means what? Where it will come now? Function 1 minus. It is 1 minus means x is 1. Sorry, x is 1 na. It can't come here. Okay, it can't come here. So it means this is 1 minus means greater than 0. 1 minus means greater than 0 wala function. So greater than 0 function is this. So it will be 1 only. I hope ki now you will take care of this point. This is near to 1 only. It can't go, that gap can't be 1. You are subtracting something na from this. 1 minus means you are subtracting something, but that subtraction is very small. That can't be 1. 1 is too big. It is something 0.000000. Infinitely many zeros and then some positive number we can expect, because we are doing some 1 minus na. So I hope you will take care. So 1 minus means it is in neighborhood of 1 only. So now tell me this value, this. She will answer now. Okay, now I think I should write 3 minus I thought this is simple one, but so this will be, you answer me now. This will be 0. See the function please. 0,
Sorry,
Greater than 0, 1 over.
then now what you did, how you said that this, and f0 is how much? F1 is how much? F1 is? F2 is? F of minus 2 is?
minus 1.
I hope you got to know. To you, I think I want, it is clear now? You will take care? Because this is a simple one actually. You get, this is simple one, but you never know which question you are getting. Okay, now come to one, okay, now different questions I'll start with. Okay. Okay. These questions are clear? Partition, basically these are, now take this question now. Your question is, x into e to the power 1 by x minus 1 e to the power 1 by x plus 1, x not equal to 0, x equal to 0, this is 0. So you have to check differentiability at x equal to 0. Any doubts? You can ask, you are free to ask. I have full liberty. Tell me if there is any doubt regarding this, whatever is going on. The differentiability of this function now. Tell me first, e to the power x function is differentiable? E to the power x function is differentiable? Any point where it is not differentiable? Tell me. You agree e to the power x is differentiable? She only agreeing and I agree with her also. Differentiable? Sin x function is differentiable?
Yes, sir.
Cos x is? Mod x is?
Not differentiable.
Please don't say not differentiable. Add 0 only. It's a big statement you are putting. Not differentiable. It means this is like this is differentiable means it is differentiable at every point. So you have to be very careful whenever you put a statement and all. Whatever you say. So mod x except 0. Okay. Now I think other function, log function. What about log?
Differentiable.
Derivative is this.
Yes, sir.
Only problem is
0.
so there is a point. So why we are saying this is differentiable? Answer is very easy. Please think about it because you know you can answer. Derivative is 1 by x. So 0 it is a problem. 0 is a problem na at derivative. So why 0 like why we say differentiable? Yes, I think you can answer. I am expecting from you. It's very easy actually. In the beginning I told you something if you recall. Think about it. It's easy. Answering at 0, it's a big problem actually. Big problem now. Limit exists of this function at 0? Okay. Okay. Ah, really? My God. She said limit of this function at 0 exists. Okay, you just left hand limit, right hand limit you give me? You give me na left hand limit, right hand limit. What will be those limits? LHL will be what? 0 minus? RHL will be? I should not put equal. RHL will be? RHL will be limit 1 by x tending to 0 plus 0 minus. So, she said limit exists. Limit exists means limit is finite. She said na limit exists, limit is finite, and continuity part I am not discussing. So, this is basically 0 minus means you are going from the left. So, this will be minus infinity. This will be, how can you say limit exists? This is not continuous at 0. This is not continuous at 0, na? If it is not continuous at 0, this is not? Okay, limit doesn't exist. If it is not continuous at 0, not differentiable at 0, but why you say log x is differentiable then? You have studied it. Sin x is differentiable, cos x is differentiable, log x is differentiable. All these functions are differentiable, but why this 0 is creating problem, but still we are saying log x is differentiable? Why? Why we are saying it? Tell me.
जब हम ग्राफ होता है log x का वो तो कंटिन्यूअस आता है ब्रेक नहीं करता log
Yeah, I am talking about derivative, not log function. I checked limit of this function only, not for this function. I asked her anyhow that limit of this function exists on it. This is a function, na? Derivative of function is a function. I asked her whether limit of this function exists or not. I showed you. That's it. I am not saying continuity thing in for this function. I am not saying anything. This is derivative of this function. So I am basically asking you. We say derivative exists. Log x derivative exists. But 1 upon x is creating problem at 0. Then why we say log x is differentiable? Okay, now tell me domain of log x. Tell me domain of log x function. These things are important. Domain of log x. Domain of log x. Okay, this is the problem actually. Domain you don't know. You remember? All positive numbers? How I write now? All those positive numbers, how I write? Can I take 0? It means you are saying greater than when I take. Greater than I take. This is what your point is. Greater than or? This is what you are saying. Log 0 is minus infinity. Log का domain is all those points which are greater than 0. 0 onwards. 0 नहीं लेते and then 0 onwards. अब मैं आपको स्टार्टिंग में ही आते ही मैंने बोला वो इम्पॉर्टेंट चीज थी. I always check differentiability at or on domain only. In domain 0 is not there. 0 is not there. So there is no point of contradicting this. Because 0 is not there, 0 is the only problem. But 0 is not lying in the domain. So we cannot check differentiability of this at 0. We will not check because this 0 is not in domain. We check differentiability and continuity at on domain points only. That is the condition. I hope it is clear now. Okay. So limit doesn't exist. Limit also, limit of this function only. This is derivative of this function. So this is totally different. This is function, this is derivative. So I asked you derivative limit exists or not. Is it fine? So 0 is creating problem but 0 is not in the domain. So not at all an issue. Is it fine? So now move to that question. You want to write something or I have the board? It means domain is also important because you are doing differentiability of a function, so you should know domain basically. What will be the, what is the domain? On what points we can talk differentiability? So first thing is that you should, whichever function you are discussing, differentiability and all, you should know the domain. So now come to this. I want to check. I want to check differentiability of this function. Okay. So before differentiability, I check continuity or I do it directly. Continuity I should check now. In case it is not continuous at 0, then no need to check differentiability. Okay. So better option is differentiability or continuity. Direct I can check, there is no harm in that, but the thing is better way is check continuity first. So I will check continuity at x equal to 0. So what will be the left hand limit? Left hand limit will be limit x tending to 0 minus, and fx is your complete this. What happened? This is left hand limit. Function is basically on both left hand limit and right hand limit, both will be same because function is same. So I can 0 minus and 0 plus, I can avoid it. I can write 0 only, but in mind it is there that 0 minus 0 plus side by side both we are calculating. So what will be this? Okay, now substitute 0 here. Substitute 0 here. So what value you are getting? You have done such type of limits because this is limit question now. This is limit question now. Have you done such type of questions in limits? You have done? Speak loudly. What will be this now value? Can you find out? Only because I want to check continuity only. So if you are able to, if you can find out left hand limit, right hand limit, easily you can answer. So what will be this limit? What value you are getting here? Okay, I just give you 1 minute. Just find out. If you know the method, it's well and good. Quickly do it. Are you able to do it or I should do it? I should do it, I think, on board. LHL, what value you are getting? 0. Okay. 0 you are getting. You are getting 0 at fine if you are getting 0. I don't know actually what value. RHL is same. So it is continuous. You have got some value, okay. Now you just match up and you just see the method, like you whatever you did, that is correct or not. Basically when you are putting 0, e to the power infinity value is, e infinity is, okay, you don't know. You should say actually. Don't take time, you just say ma'am we don't know. Log x function and ex function, okay, I am telling you. Log infinity is infinity. E to the power infinity is infinity. Log 0 is minus infinity. E to the power minus infinity is, there is formula also for all these things, but you just now for this question, e to the power minus infinity is 0. In case you don't know log 0 value, just apply log here. Minus infinity log e will be log 0. Log e value is 1. So minus infinity is log 0. So this way also you can do it. So E infinity, okay, one more help I can do it. E to the power x expansion, you know that this is the expansion.
Yes, ma'am.
So when you will substitute infinity, so this sum will be infinity, okay. E infinity will be infinity. Apply log on both sides. So log infinity value, what value you are getting? Infinity only. Fine. Now tell me e to the power 0, which you know. E to the power 0 is 1. So apply log on both sides. So log 0 log e will be log 1. So 0 will be, and log 1 value you know. But this way also you can find out. You know this expansion. E to the power minus infinity, now tell me. E to the power minus infinity. This is a good question. E to the power minus infinity. E to the power minus infinity, when you put up, what value you are getting in this here? E to the power minus infinity will be 0. E to the power minus infinity value will be 0. Now I hope all these values you got to know. Now come to this limit point now. You have noted down? These values actually you should learn, because every time you now with the help of this expansion you can find out, but you should know all these values. Now come to this limit. When you are substituting 0, this is E infinity, this is E infinity. For such questions, if you are getting infinity na, what you do, you just take out that part outside. You just take out that part outside. So take out this e to the power 1 by x common. So what you will inside within the interval, what you will get? 1 minus e to the power 1 minus x. E to the power 1 by x, from here also you take out common. So it will be 1 plus 1 minus x. Now this gets cancelled. X is there, no problem. 1 minus e to the power minus 1 upon x. E to the power minus infinity. E to the power minus infinity value is 0. Now there is no problem. Basically, when you find out limit of any function na, and infinity if you get, then you have to think like what to do to remove that. In case like, because from here you were getting some other value na. So now this is how you solved it. This is how you did it. I don't know, like, but with whichever method you apply, your answer was correct. That's why I just told you to learn this method also. So this is 1 minus 0, 1 plus 0, 1 only, and multiplication of 1 with 0. So it is 0. And f of 0 is also 0. F of 0 is also 0. So this function is continuous. Now the question is, may or may not be differentiable. May or may not be differentiable. That we will do. So differentiability, now we will check. Differentiability at x equal to 0. So right hand limit will be right hand derivative, then left hand derivative at 0. Both will be same. Both will be same. If you have noted down, I just rub it, and I will remove this only. There is, I think I should write again. So differentiability, right derivative will be what? Limit x tending to 0 plus fx minus f0 upon x minus 0. So fx value at both right hand derivative, left hand derivative, both will be same. Okay, so both should exist. So limit, I am just rubbing it because both limits will come out to be same. So limit x tending to 0, fx value is x e to the power 1 by x minus 1 e to the power 1 by x plus 1. Is it fine? Something x I left actually. X will get cancelled. Now tell me, like you were applying some formula na. With the help of that formula, you just tell me this limit now. I just want to check like what you were doing. With x you did something. Now there is no x. You find out limit of this now. This is which form now? Infinity by infinity. Okay. Very difficult, infinity by infinity. What you will do? Okay. L हो पता है? Do it. Keep on doing it. Actually, it's a good question. Do it. Differentiate both numerator and denominator. What value you are getting? When you are differentiating numerator, what value you are getting? E to the power 1 by x same. Then
e to the power
minus 1 by x square. Then but especially for these type of functions, I'll advise you this is done. Okay, one you can get, you are getting. From here, which part is becoming infinity? This part, na? Take it outside. Okay, this part is becoming infinity. Take it outside. So limit x tending to 0. Actually, I am telling you some different method. This is one method. You can find out the value. But this is for exponential functions. We do like that to make it simple. So e to the power 1 by x when you take out, e to the power 1 by x when you take out, inside you will left with.
e to the power minus 1 by x.
So this gets cancelled. E to the power minus infinity will be 0. So ultimately answer is 1. So this is basically at 0 your derivative is 1 value you are getting differentiable. Is it fine? Now the same thing you will do for okay, one more question. I am just changing it little bit. Done this question? I am just changing it little bit and now I want first from you and then I'll do it. Whether you are able to do it or not. I am just making this change. Now what about differentiability of this function? Do it. Quickly do it. The same way. You can apply L Hopital. You can find the limit by the method you are using. Do it. And tell me whether left hand derivative or right hand derivative are same or not. First you check continuity also. First you should check continuity also. What limit you are getting? 0, 0 you are getting continuous. So it means that there may or may not be situation for differentiability. So check it also. 1 you are getting same thing you are getting. So this means this function is differentiable. If I change it to this, what will be your answer in that case? This. Now do it. This is the last question. What about this function now? Continuity and differentiability. This is the last question. So how you are doing it? You are applying L'Hopital, or you are using this technique. Infinity part you are taking out. This
Yes, sir. The one you. From infinity part.
infinity by infinity form, the best thing is take out the infinity factor
Yes, sir.
outside and then cancel it, and then it becomes simpler actually. This is technique. Otherwise you can do it by L'Hopital, you can do apply other method also. Okay, now for this question, just answer quickly. And then you will answer me, because now you are able to answer all these questions. How much time left? Okay. So I thought I should discuss that question also. Something wrong, I think. Mod x plus mod x minus 1. Under root, which function she is giving? At which point she is asking? At which point? No. If y is this, limit in general we don't talk. At some point we talk. Limit concept is at a point, not an interval. Got it? Continuous? Where is the problem? Limit, like if you are checking continuity, so limit extending to 0 plus 0 minus the same function. So this is becoming infinity. Plus 1, don't bother. This is 0. So now this is not 0 by 0 form. This is not infinity by infinity form. What change you should do? What change you should do to make it 0 by 0 either or infinity by infinity? What change you should do? Why are you making it complicated? Just do some changes here, na? You just multiply and divide by x square. This will become 1 by x, okay? And take this x squared, keep it as it is, or you can do like some changes also. Directly you are not getting, I just rub it. I'm just checking differentiability now directly. 0 left hand derivative and right hand derivative. This will be fx minus f0 upon x minus 0. If it is differentiable, it will be continuous. Okay. So limit extending to 0, fx value is e to the power 1 by x plus 1, then upon x, x we were having now. So x into x. So if I make it, I think this x is creating problem. Just assume, because I asked you, if I make it 1 by x, then what will be the answer? I'm just making it little simpler because that is creating problem, this x. And we don't have time to make changes. 1 by x. It will be 0, 0. This is a parabola basically. So what value you are getting for this? Now you answer this. You have one formula now. Limit extending to 0, e to the power x minus 1 upon x. This is how much? This is how much? If I make it infinity, this will be how much? This will be how much? That answer you got to know. X to the power 0, at x equal to 0, this value will be what? Because you got to know. if it is 0, if this power is 0 tending to 0 and this is also 0, this is 1. If in case this is tending to infinity, this is also infinity, what value you will get? This is the same question, na? This limit you are finding, and this is also of the type, this is e to the power infinity, this is also infinity. So what answer you will get now in this case? Limit extending to infinity, e to the power 1 by x plus 1, e to the power infinity, oh sorry, 0. E to the power infinity, infinity, 1 upon 0 is also infinity. What you will do? What you will do? You will L hopitai? Okay, so L hopitai will be e to the power 1 by x then into minus 1 by x square, and in denominator also limit extending to 0. So ultimately this gets cancelled, and e to the power infinity is what now your conclusion is for continuity. Okay, thank you so much. What your conclusion is now, continuity? कुछ limit आई, infinity आई, so what will be your conclusion?